nature of matter. So in this class, we are going to discuss about the physical nature of matter. So before this topic, that is physical nature of matter, let us define what is a matter and what is the significance regarding the matter. So what is the matter? Let us see. So matter is the material of which everything in this universe is in everything in the universe and in around us is made up of different shapes. Okay, so matter is the material in which everything, whatever we think in our surrounding, that is everything made up of matter, from our body to each and everything whatever we see through our eye, everything, and those things which are not also seen through our eyes, they are also consist of matter. So matter composed of everything of our universe. Now if then how can you define this matter? So matter is anything that occupies space and has mass. So the air, let us take the example of air. Air has a mass and air occupies space, but it is not seen through our naked eye. So still, that's why it is regarded as a matter, because anything which has mass and occupies space can be regarded as matter. Now matter has the third property, that is it offers resistance to the applied force. So if you are applying any force to the matter, they will try to oppose that force, and this opposing force is known as resistance. Okay, so anything that has mass, occupies space, and offer resistance to the um, opposing applied force, that is known as your matter. Now let us see some of the fundamental properties associated with matter. So there are two major fundamental property associated with matter. First is matter is made up of particles, and the second one is particles of matter are very small. So one thing about the matter is that matter is made up of particles, and the second one is particles of matter are very small. Okay, so these are the two common or fundamental property that is associated with any kind of matter. Okay, matter is made up of particles, and the second one is particles of matter are very small. Now let us prove that through certain experiment, that whatever the property that we are dealing with the matter, that is true. So in order to prove this two property, let us take suitable examples. So the first property is matter is made up of particles. So in that I have taken the example. This concept can be explained by using the example of dissolution of salt in water. Okay, so when we dissolve salt in water, the particles of salt get into the space between the particles of water, hence the water level will remain same. So what you will find that when we are mixing two or more matter, then there must be change in space of the matter. Okay, because there is a we know that we are adding two substances. One is a salt, so another is your water. So both are matter. So if adding both the matter, then there must be increase in mass and volume of the matter, or space occupied by the matter. But in this case you will find that whenever we are mixing salt to the water level does not changes. So what is the reason behind it? Okay, the reason behind it is because water contain many spaces in between the water molecules, and those spaces they are occupied by these salt ions or salt molecules, and thereby the water level will not changes. Okay, this indicates that matters are made up of particles. Okay, so this indicates that matters are made up of particles. So that's why it is not possible to change the volume in each and every case. Okay, now let us see the second, the particles of matter are very small. Okay, so particles of matter are very small. That can be explained by using the second activity, by using the potassium permanganate crystals. Now this potassium permanganate is a purple color crystal having the shape of a your you can say your salt like, but the color of this salt will be purple color. So what happened when we are this can be explained by dissolving few crystals of potassium permanganate to color a large volume of water. So this indicates that there must be a large number of tiny particles in just one crystals of potassium permanganate, that is particles of matter are very small. So what we need is we need a glass beaker, and we have added, you see, we have added two particles of your sodium potassium permanganate. When we are adding this potassium permanganate in this solution, the whole solution become pink in color. Now what we will do is we will take 10 ml from this 100 ml. then again we will add to the 100 ml of water. You see, again these also become pink. Then what is the difference between these two? The difference is their intensity. Here the color intensity is more, here the color intensity is less still, but there is a pinkness here. Again you will take the 10 ml of this solution, again add to the 100 ml, then you will again find that again it will change into light pink color. Now what is the difference? Here see the intensity of the color. Here the intensity of the color changes. Again take 10 ml and add it to the 100 ml. Here also we have the change in color. But in all this, what you will find that although in all the cases we are saying that there is change in color, but the intensity of the color will be different in all the cases. The reason behind it is because the matter where that is your here potassium permanganate is splitting into several small matters, and with the increase decrease in size of the matter become completely transparent. So when you'll go on doing for a very say 5 or 6 times, then you will find that the solution become completely colorless, although that solution contain potassium permanganate particles, but those particles are so small that it is not imparting color to the water. So this activity, ये activity prove करता है कि आपका जो matter होगा वो small particle से बना हुआ है. तो पहले में हमने 2 crystal डाला तो pink हो गया, dark pink. now इसको फिर से आप इसको water में डालेंगे 100 ml, तो फिर से ये light pink हो गया, इसको और करेंगे और भी light हो गया और भी light. ऐसे करके आप और 6 या 7 स्टेप में आप देखोगे कि completely transparent solution हो जाएगा. ये क्या इंडिकेट करता है कि जो मैटर है, यहाँ में कौन सा मैटर है, पोटेशियम परमैंगनेट, वो बहुत ही छोटे पार्टिकल से बना है. तो जैसे जैसे आप उसको डाइल्यूट करते जाओगे या जैसे जैसे उसमें और पानी वाटर ऐड करते जाओगे, आप देखोगे कि वो और छोटा छोटा होते जाएगा. एक ऐसा टाइम आएगा that it becomes completely transparent. It indicates that now very few particles are there in the water as compared to the water. Okay, ऐसा नहीं है कि particles कम होंगे, only what we are saying is where the number of particles will become less as compared to the number of particles of or the number of molecules of water. So this is how we can say that particles of matter are very small. And now we'll discuss about the next property, that is characteristic of particles of matter. Now these particles have certain property. Now there are 3 main property that is associated with particles of matter. So any matter, they consist of these 3 characteristics. Okay, so particles of matter have space between them. ये particles के बीच में space होते हैं. First, the particles of matter are continuously moving. Okay, the matters which is made up of particles, they are in continuous motion. And the third one is particles of matter attract each other. Now let us see one by one then what are the characteristics of these particles of matter. The first characteristics is particles are in constant random motion. So what happens when we are increasing the temperature or we are increasing the kinetic energy? So particles of the motion, they are taking the energy from the heat and they are moving at a higher kinetic energy, and thereby they are in constant rapid motion. Okay, unlike in the first case, here there is increase in motion of the particles. Okay, now the movement of particle is minimum in solid, more in liquids, and maximum in gaseous state. So what is the difference? Although the particles are in motion, but it depends upon the type of arrangement of the particles. In solid, the particles of the substance are very closely packed or they are very near to each other. So the motion is not very frequent. In liquids, the particles are near to each other, but there is a gap. So that's why the motion will be more. And in case of gases, the particles are in a constant rapid motion, and it increases with increase in टेम्परेचर. जितने ज्यादा टेम्परेचर इंक्रीज करोगे उतनी ही ज्यादा मोशन होगी. तो ये मोशन किसकी वजह से होते हैं? बिकॉज ऑफ द काइनेटिक एनर्जी एक्वायर्ड बाय दिस पार्टिकल व्हेन द सब्सटेंस इज हीटेड. नाउ अगर इस मोशन को आपको स्टॉप करना है, इफ यू वांट टू स्टॉप ऑल द मोशंस रिलेटेड टू दिस पार्टिकल्स, देन व्हाट वी कैन डू इज वी कैन डिक्रीज द टेम्परेचर. जैसे जैसे टेम्परेचर को डिक्रीज करोगे, मॉलिक्यूलर वाइब्रेशन और मोशन ऑफ द पार्टिकल डिक्रीजेस. और मॉलिक्यूल्स ऑफ द वाइब्रेशन, अगर वाइब्रेशन डिक्रीज करेगा तो उसकी मोशन भी क्या हो जाएगी? ऑलमोस्ट ceases to exist. And एक ऐसा टाइम आएगा जब the motion become almost negligible. वो कब आएगा? when the matter is subjected to minus 273 degree Celsius, और that is also equal to 0 Kelvin. अगर किसी सब्सटेंस को बहुत लो टेम्परेचर में रखा जाए, जैसे minus 273 डिग्री सेल्सियस, बहुत ही कम टेम्परेचर, उसमें सारे इसके मोशन क्या हो जाएंगे? Almost become 0. But that is the ideal case and that does not occurs. Why? Because minus 273 is not cannot be attained in any lab or any other machine. So that's why that concept is just a theoretical rather not a practical concept. Now next is particles of sorry particles of matter have a space between them. Okay, so what we find is there is a space between particles of matter, and that can be explained before that we have seen how uh, when we are adding sugar or salt to the water, these sugar and salt, they will enter the interatomic space or the space between the particles of matter, and thereby they will not increase the level. So it also indicates that the particles of the matter have space in between them. So when we make tea, coffee, or lemonade, okay, particles of one type of matter get into the space between the particles of other. This shows that there is enough space between the particles of matter. So what happens when we are mixing these two substances? When we are mixing these two substances, we will finding that the matter. Okay, when we are mixing these two substances, we are finding that matter from one space, from one substance will enter the enter atomic or the space between the other substances. Okay, so thereby we can say that all the particles of the matter have space in between them, but some spaces are small, some are bigger. So the smaller particles will enter the spaces of the bigger molecules. Okay, so that's why now the next concept is the space between the particles is minimum in solids, intermediate in liquids, and maximum in gas state. That is common because of the arrangement of the particles. Why? Because in solid you will find that the particles are very near to each other, so there is no space in between them. But in liquids there is some space between them, and those allows the particles from others to enter here. Okay, other particles that is from other matter, they will enter in that space. And in gaseous state there are large number of space, so any matter can enter from in that interatomic spaces. Now the third one is particles of matter attract each other. Okay, so when we open a tap water, try to break the stream of water with your finger. Can you do this? No, because the stream of water remain together. The particles of water are held together because of the force of attraction between them. So what happens, when we are opening the tap, we are trying to separate the particles. That okay, temporarily it may separate, but again they will join together. Why? Because they are held together by a very strong force of attraction, that is known as hydrogen bonding, and that is a very strong force. So once you are removing the hand, again they are going to bind together by that strong force of attraction. And that's why it is said that the particles of the matter, they are having different kind of force of attraction. Some are strong, some are weak. Okay, it depends upon the particles of the matter, nature of the particles of matter. Now the next is the force of attraction between the particles is strongest in solid, intermediate in liquids, and weakest in gaseous state. Again the reason is type of arrangement. Arrangement ultimately, so arrangement decide the nature of the particles. So the force of attraction is strongest in solids. Why? Because the molecules are very near to each other, so they will be attracted more. Okay. Now, if the molecules are very far or farther from each other, then there will be attraction will be less. And what about in case of gaseous state? The molecules are very far from each other, so there is very less attraction. Okay. So this is all about your particles of matter. Now, let us see the arrangement of particles in different states of matter. In solid, you will see that the particles are very uniformly and very compactly arranged with each other. Okay, there is a very small gap, or the gap is not sufficient to accommodate any bigger particles. So, okay, very small particles can come, but mostly the bigger particle is not accommodated by this gap. See, in liquid, although their gap is also less, but as compared to solid, there is more gap. So as compared to solid, more bigger particle can enter here. What about in gas state? You see, there is a large gap between the particles. So another particle can also enter in this gap, and that's why it shows heavy, large interatomic spaces. Okay. Now, here are some questions related to the topics that we discussed. Give the reason for the following observation. First, the smell of the hot sizzling food reaches you several meters away, but to get the smell from the cold food, you have to go close. Second, a diver is able to cut through water in a swimming pool. Which property of matter does this observation show? Now, the class